Hi all. So today I'm going to discuss the topic random variable. So it is a basic concept of a field called probability. So in probability, we always start with the random variable. A random variable is a function x from a sample space to the real number space. Okay, so whenever we say a function, it includes domain and a codomain. So here the domain is the sample space of a random variable, and the range space is the codomain is the real number space here. Because domain means we are going to take a problem from that. Okay, the range space, real space will give you a output. So we can relate this to a function x from capital S to R. Okay, so here this refers to a sample space, and this is a maybe we can say a real number from 0 to 1 with a closed interval, right? Yes. So let us do one problem. Like, what is the probability of by tossing two points? So we can associate this problem to the random variable, right? So let us take the random variable capital X as number of heads by tossing 2 points. So number of heads obtained by tossing 2 points. So what are all the possible ways? Okay, so that will be denoted by small x, and the probability also will be noted, right? So we can have the possibility of 0 heads, 1 head, and 2 heads, right? And in how many ways you will get the 0 heads? So this is the sample space for this. 2 heads, a head and tail, and order can be changed, right? So tail and head, then tail and tail. Okay. So here, if you consider this, so here we have 2 heads, here we have 1 head, here we have 1 head, and here we have 0 heads. So this 1 out of 4 times I have 0 heads, and 1 head is obtained 2 times out of 4, and 2 heads is obtained at 1 number of times out of 4. Okay, so this is the values of head obtained 0, 1, and 2, and the respective probabilities are written here, right? Now we are asked to find what is the probability of getting a head by tossing 2 points. So this is our answer. So the probability of x equal to 1 is equal to 1 by 4, right? So this is the basic example of how to understand the variable, random variable, right? So next we will move on to the basic problem. Usually they ask these kind of problems that a random variable X has the following probability function, that is X and P of X. So here we have the values of X as 0, 1, 2, 3, 4, 5, 6, and 7. So their values are 0, K, 2K, 2K, and then 3K, K square, 2K square, 7K square plus K, right? And we are asked to find K value, and P of X less than 6, and P of X greater than or equal to 6, and P of 0 less than X 0 less than 5. And option C is distribution function of X. Option D is P of 1.5 less than X less than 4.5 with a condition X greater than 2, and expectation of 3x minus 4, variance of 3x minus 4, and the last one is if probability of X less than or equal to C is greater than 1 by 2, then what is the minimum value of C? Okay. So these are the subdivisions we have to work out now. So we will do one by one, right? So now if you see this, so we are given the problem here. Yes. So this is what the table we are given, right? So we know the concept called total probability. So total probability is always 1. Okay, so the formula for it is summation all the probability value is equal to 1. So here if you look at this, we have the values as 0, then K, then 2K, then 2K, and then 3K, and then K square, then 2K square, then 7K square plus K, which is equal to 1. So if you add all of them, you will get 10K square. And how many Ks are there? 1, 2, 2, 3. So it is 8. Then one more, it is 9 is equal to 1. So we can bring that 1 here on the other side. So it is equal to 0. Okay, so it is a quadratic equation. And if you solve it, it will become minus 10. And then so 10 into 1. So 10 minus 1. This. Okay. So divide by 10 and 10. So you can cancel this. So this is 1 and 1. So we have K plus 1 and 10K minus 1 equal to 0. So if you equate 0 the each and every term here. So we get k which is equal to -1 and k is equal to 1 by 10. So obviously we are going to eliminate this and we are going to take this, right? So our k value will be 1 by 10 for this problem, right? So obviously if you are not asked to find k, you have to find it, right? Because based on the k value only, they are going to find out all the other subdivisions. So the first option, they usually ask the value of k or the value of c, whatever the constants involving in the probability, right? So now we are moving to option B. Yes. So the option B is we have to evaluate the values of probability of x less than 6, probability of x greater than or equal to 6, and the value of probability of 0 less than x less than 5, right? So if you see this, the value of x less than 6, it is equal to the probability value can be 0, the probability value can be 1, the probability value can be 2, the probability value can be 3, or the probability value can be 4, or probability value can be 5. So since it is given strictly less than 6, we are not taking 6. So and why we are adding all these probabilities? Why can't we multiply them? So whenever you are asked, if it is x less than 6 means it represents either 0 or 1 or 2 or 3 or 4 or 5. So okay. So whenever you are using the term or, we have to use addition as our operation. So whenever we are using and as our term, we have to use the multiplication. So this is the basic rule of probability. So that is why we are adding all these terms, right? So now we have to look at the values here. So the values are 0, k, 2k, 2k, 3k, and k square, right? So it is 0, k, 2k, and again one more 2k, then 3k, and then k square. So if you add all of them, it will become k square plus 8k. So now you can apply the value of k here, so which is 10, right? So if you square, it will become 1 by 100, and it is 8 by 10. So if you take LCM, it will become 80 by 100. So it is going to be 81 by 100, right? And the next term is p of x greater than or equal to 6. So what is greater than or equal to 6? So it is the remaining terms, like we have p of x equal to 6 and p of x equal to 7, right? So for x equal to 6, what is the probability value? Which is 2k square, and then the next term it is 7k square plus k. So if you add them, it will become 9k square plus k. So it is 9 by 100 plus 1 by 10. So it is 19 by 100. So if you look at this probability of x equal to less than 6 and x greater than or equal to 6, you can identify one thing. That is, if you subtract this 81 by 100 with 1, we will get this 19 by 100. So these are the these probabilities value always will be equal to 1. Whenever you are taking a point and you are taking the left side and the right side of it, if you add them, it will give you a total number of probabilities, right? Next, we are moving on to the next option, that is 0 less than x less than 5. So here, if you say 0 less than x less than 5, okay, we are using less than symbol. So we should avoid the boundary points. So we have to take x equal to 1 or x equal to 2 or x equal to 3 or x equal to 4. So you should not include 0 and 5 here. So for 1 it is k, and for it is 2k, and then 2k, then 3k. So add them, it is 8k. So it is 8 by 10. So this is the probability we have. Yes. So the next subdivision is distribution function of x. So the distribution function of x can be calculated as, so here we have several values of x, and the distribution of x is slightly different from probability value, right? So the formula for it is f of x equal to x is equal to p of x less than or equal to x, right? So for example, if you want to find f of 5, if you want to find the probability distributive function of 5, then I have to go for this x less than or equal to 5. So it is like I have to start with 0, then 1, then 2, then etc. up to till 5. I have to add. So this is the distribution function of x. So we can calculate for all, that is, we are given x values and we know the probability values. Now we can add them, right? So what is the value of x here? 0, 1, 2, 3, 4, 5, 6, and then 7. So now the probability values are given as 0, 1 by 10, 2 by 10, 2 by 10, 3 by 10, 1 by 100, 2 by 100, and it is 7k square plus k, which is 17 by 100, right? So now add this, right? You add this probability up to 0. You add the probability up to 1. You add the probability up to 2. You add the probability up to 3 and up to 4 and up to this, that is 81 by 100, and then 83 by 100 and 100 by 100, which is equal to 1, right? So always remember that this 1 should be your final distribution value. So distribution value means we are adding up to the given value. So whenever you take the final value, it should be equal to 1, because that is the probability function, right? Yes. So next we are moving on to find from 1.5 to 4.5. And with the condition x is greater than 2. So what is this conditional probability? So we have two statements, and one is an actual statement, the other one is a conditional statement. Okay, so with that statement, I am putting one more condition, so it becomes a conditional probability. So the formula for this is probability of A intersection B by probability of B, right? So here we are given A condition as 1.5 to 4.5, and the x greater than 2 is our P, right? So this is my A and this is B, right? So I can very well use this formula from 1.5 to 4.5 and x greater than 2 can be written as probability of 1.5 less than x less than 4.5. Okay. Intersection x greater than 2 and divide by probability of x greater than 2. Yes. Now, the values of this 1.5 to 4.5, since it is discrete, we can take from 2, 3, 4, right? And here it is from 2, it is starting. So all together, if you put the intersection, you will get only probability of x equal to 3 and the probability of x equal to 4. Right? And here we are given probability of x is greater than 2. So what is probability of x is greater than 2? So we can calculate in the other way, that is 1 minus probability of x less than or equal to 2. So for 3 and 4, what are the probabilities? So for 3 and 4, yeah, 2k and 3k. And for less than or equal to 2, it is only 0 and 1, right? So for 0 and 1, I can add 0 and k. Yeah. Also, we have to add this 2k once again, right? So it becomes 5k divided by 1 minus 3k. So it is 5 by 10, 1 divided by 3 by 10. So 5 by 10, if you take an LCM, 7 by 10. So it is 5 by 7, right? So this is the value of this conditional probability. So I hope you understand what is conditional probability here, right? So next we are moving on to the option which is E, right? Yes. So that option is we should find out the expectation of 3x minus 4 and variance of 3x minus 4. Yes. So what is the expectation? So we have a formula for expectation which is summation xi into the probabilities of xi where I runs from 1 to n. Right. So here if you apply this problem formula here, we can find out what is expectation of x. So the expectation of x will become xi. So what is xi? So if you apply I equal to 1 to n, it will become x1 into p of x, x2 into p of x2, like that. Okay. So the value and the probability value of it. So both are 0 and 0. And for 1 it is k, and for 2 it is 2k, and for 3 it is 2k again. And now for 4, it is 3k, and for 5 it is k square, and for 6 it is 2k square, and for 7 it is 7k square plus k. Okay. So now if you add, it will become 0, k, 4k, 6k, and then 12k, and then 5k square, 12k square, plus so you add all the k squares here. So it is going to be 54 and 66 k square. Right. And the values of k are 1, 4 and 6, 10, 11, then 23k, and it is going to be 30k. So it is 66 by 100 plus 30 by 10. So if you add 1 0, it will become 300. So it is 366 by 100. So expectation value no need to lie in between 0 and 1. So it can exceed 1. It can be a negative value. So no problem with that, right? So this is just the expectation value of x. So now we are finding out the expectation of 3x minus 4, right? So now what should we do? We should apply this expectation inside every function 3x and expectation of 4. So expectation of 3x can be written as 3 times expectation of x minus what is the constant expectation? It is a constant, right? So it is simply 4. And now I have 3 into 366 by 100. Then, yeah, minus 4. So if you multiply, you can get this. So it is 400. So it is 698 by 100. So these are the expectation value of expectation of 3x minus 4. And we have the term called variance of 3x minus 4, right? So variance means we have to write like this. The constant will be squared and variance of x minus variance of 4, right? So it is going to be 0. Variance of 4 is 0. Okay. For every constant value, the variance is always 0. So this is simply 9 variance of 4. Sorry, variance of x. So how to find the variance of x? So the formula for variance of x is expectation of x square minus expectation of x the whole square. So this expectation of x square value can be find out using this summation of xi square into the probability of xi, right? So we should multiply each and every term. We have to become to square each and every term given, and we should multiply the probability of it. So the expectation of x square is 0 square into 0 plus 1 square into k, which is 1 by 10. 2 square into 2 by 10 plus 3 square into 2 by 10 plus 4 square into 3 by 10. 5 square into k square, which is 1 by 100. 6 square into 2k square, right? So it is 2 by 100 plus 7 square into 17 by 100. So if you add all of them, first value is 0 and we have 1 by 10 plus this is going to be 8 by 10 plus 18 by 10 and 48 by 10, 2500, and then 36. So if you multiply, it will become 72 by 100, and then 49 into 17. So 833 by 100. So if you add all of them, it will become 75 by 10 plus, so it is going to be 905 to 930. So it is 750. So it is this is going to be the expectation of x square. Now, so this variance of x is the expectation of x square minus expectation of x the whole square. So it is going to be 1680 by 100 minus it is 366 by 100, right? So this will give you a variance of x value. Next, we have to multiply this value with 9. So it will give you a total value of variance of 3x minus 2. And the last one we have is if the probability is less than or equal to some value, and the value is actually greater than 1 by 2, then what is the minimum value of C? Okay, this is what asked here. So now we can find out this using, if you randomly put C equal to 0, this will give you probability of x less than or equal to 0. So x less than or equal to 0 means it is x equal to 0 alone. So x equal to 0, the probability is 0. It is not greater than 1 by 2, right? This is not greater than 1 by 2. So I can take the value of C equal to 1. So probability of x less than or equal to 1 is 1. It is 0 and 1. So it is k. Probability is k. So it is 1 by 10. So this is also not greater than 1 by 2. And if I replace C equal to 2, it will become probability of x less than or equal to 2 is equal to 0k and then 2k. So it is going to be 3 by 10. So still it is not greater than 1 by 2. And if you go for C equal to 3, the probability of x less than or equal to 3 is equal to, one more 2k I have to add. So it is 5 by 10. This is not greater than 1 by 2. It is equal to 1 by 2, right? So the next value I will be taking is C equal to 4. So for this, the probability x less than or equal to 4, it is, I have to add 3k with it. So it is going to be 8 by 10. So it is 8 by 10. So it is less than 1 by 2. So the minimum value of C is equal to 4, right? So actually, this is a big problem, and it explains the concept of random variable very well. Okay, so the random variable can take the value of this 0, 1, 2, etc. up to 7, and the probability values are given we found out the value of k and we move on to find out the next values, right? So by looking at this problem, we can say that this random variables are of two types. So they are called discrete and continuous. So we have a random variable called discrete random variable. And continuous random variable, right? So that depends on the values of the random variable it is taking. Okay, so depends on the problem, we will fix our random variable, either discrete or continuous. Okay, so it is called as the types of random variable. So the example we have seen is the example for a discrete random variable, right? And for continuous random variable, we can look at one more problem now. Yes. Now we can look at the problem on continuous random variable. So which is a random variable x as the PDF, that is a probability density function. Okay. It has the PDF, which is f of x is equal to 2x and it is 0. So whenever x is from 0 to 1 plus 2x, otherwise it will be 0. So now we should find out the values of probability of x less than 1 by 2 and probability of x is between 1 by 4 to 1 by 2 and probability of x greater than 3 by 4 with the condition x greater than 1 by 2. Okay. So we are given that the f of x will take the value of 2x and 0 otherwise. Okay. So whenever we have from 0 to 1 will be 2x. Yes. So we can simply take this f of x equal to 2x whenever x is in between 0 to 1. So now the first subdivision we are asked to find is probability of x is less than 1 by 2. So if it is x less than 1 by 2, so we have to use the integral here, and the lower limit is 0, upper limit is 1 by 2. And f of x dx. So what is f of x? It is 2x dx and 0 to 1 by 2. So I can take this 2 out of this integral and I have x. So if you integrate, it will become x square by 2 from 0 to 1. So 2 will get cancelled. So if you apply the limits, it will become 1 square minus 0 square, which is going to be 1. So this is going to be 1 by 4. And So I am taking from 1 by 4 to 1 by 2. So it is 1 by 4, obviously it is a lower limit, and 1 by 2 will play upper limit, and f of x dx. So it is going to be f of x is again 2x dx. The limit is from 1 by 4 to 1 by 2. So now if you integrate this, it will become x squared by 2. And from 1 by 4 to 1 by 2, right? So this 2 and 2 will get cancelled. Now I have x squared from 1 by 4 to 1 by 2. So now if I apply this from 1 by 2 square minus 1 by 4 square. So it is going to be 1 by 4 minus 1 by 16. So how to subtract this? So take LCM here. So 16 is an LCM. So it is 4 times minus 1, that is 3 by 16, right? So the last option is the conditional probability again. So we have already gone through what is conditional probability. Now it is a matter of continuous random variable, right? So the same formula applies here. So probability of A intersection B, right? X greater than 3 by 4 intersection x greater than 1 by 2 divided by x greater than 1 by 2. So now, if it is x is greater than 3 by 4 and x is greater than 1 by 2, what is the value I have to take? So if it is greater than means I have to go for the highest value. So the highest value is 3 by 4. So I have to take this x greater than 3 by 4 and x greater than 1 by 2. So x greater than 3 by 4 means the probability value will be like this. From 0 to 3 by 4, this f of x dx divided by 0 to 1 by 2 f of x dx. So it is going to be 0 to 3 by 4 2x dx and 0 to 1 by 2 again 2x dx, right? So now 2 will get cancelled. So here I have x square from 0 to 3 by 4. And again I have x square from 0 to 1 by 2. Yes. So now we can solve this using 3 by 16 minus, 9 by 16 minus 0. On the other side, it is going to be so 1 by 4 minus 0. So it is 9 by 4. Yes. So here the values are like we should take them in upper limit. So it is going to be 3 by 4 to 1 dx dx and 1 by 2 to 1, 2x dx. Obviously, 2 will get cancelled. So x square by 2 also will get cancelled. So it is x square and 3 by 4 to 1 and x square from 1 by 2 to 1. Okay. So it is going to be 1 minus 9 by 16 and 1 minus 1 by 4. So it is 7 by 16 and 3 by 4. So if you cancel, it will become 7 by 12.
Yeah, hi students. So in this video, I am going to talk about the concept maxima and minima. Okay, so this comes under the functions of several variables. Okay, so if you look at generally what is maxima and minima, so we are given a function, we can find the maximum and minimum value. Okay, so if you find the graph for the function, by looking at the graph, we can say this is the maximum point and this is the minimum point. But if the function is some higher order function, okay, if it is having power 3 and power 4, we are not able to find the graph of those functions manually. Okay, so in those cases, we use the concept of differentiations. Okay, so mathematician Fermat has found out the concept of maxima and minima by using the concept of derivatives differentiation in that. Okay, so we are going to see that in this video. So if you are given a function y equal to f of x, right? So we can find the graph of that function. Suppose, so this is my f of x for this given function. Okay, so by looking at this graph, I can say this is my maximum point and this is my minimum point. Okay, so this is the maximum value and this is the minimum value of this graph. So here we have a concept called local maximum or minimum and global maximum or minimum. So this local maximum minimum refers to the given region. Okay, so we take a region of this and we say within this region what are the maximum points and what are the minimum points. They are called local maximum and local minimum. So global maximum and global minimum is for the entire region of this x axis and the region, right? Okay, so here we have formed this maximum and minimum value. So this maximum and minimum value, if you look at this graph, we have a deep differentiation in this, right? So this maximum point here, we have a increasing function here, and suddenly this is getting decreased. So here this function is getting decreased and suddenly it is increasing. So there is a change in this point. So these points are called the stationary points. So in differentiation, how we can obtain the stationary points? So if you differentiate the particular function at that particular stationary point, the differentiation will get 0. Okay, so that is why we are using this derivative concept in the maxima minima, right? So now we will write a problem and we will solve it. So find the maxima and minima of f of x equal to x power 3 plus y power 3 minus 12x minus 3y plus 20. Yes. So we are given the function which is f of x equal to x power 3 plus y power 3 minus 12x minus 3y plus 20. So the working procedure is so the given function f of x comma y equal to x power 3 plus y power 3 minus 12x minus 3y plus 20. So the working procedure is we have to find the partial order differentiations which is dou f by dou x and then dou f by dou y, then the second order differentiations which are dou square f by dou x square, then dou square f by dou x dou y and dou square f by dou y square. So we name them as P, Q, R, then S and then T, right. So these alphabets refers to the values of the first order and the second order derivatives, because we are going to use this in our calculations. Okay. So we will find out what is this P value, Q value, R, S and then T. So what will be this P value? So here this P value is nothing but dou f by dou x. So that is the partial differentiation of this function with respect to x. So if you differentiate this with respect to x, it will become 3x square plus, so this y power 3, there is no term x in that. So it will completely become 0 because it is considering as a constant when we differentiate partially with respect to x. So that is 0 and this minus 12x will become minus 12 into 1 which is minus 12. This minus 3y will become 0 and 20 also will become 0. So finally we have 3x square minus 12 and we are going for the value q. So which is the value of dou f by dou y. Yes. So now we are going to differentiate this function with respect to y partially. So the first term will become 0. So the second term will become 3y square and then 0 minus 3 and 0. So this becomes 3y square minus 3. So next we have the value of r, which is dou square f by dou x square. So already we have done for 1x partially. So it is for x square means we have to do that once again with respect to x. Okay. So already we have 3x square minus 12, right. So differentiate this term with respect to x again partially. So it becomes 6x minus 0. So it is 6x. Okay. And so we can continue with this x, s and t value. So here this s equal to dou square f by dou x and dou y. So already we have done for dou f by dou x. So this term can be taken and this can be differentiated y partially to obtain this value. So if you differentiate this with respect to y, it will completely become 0. And we have the last term which is t, that is dou square f by dou y square, which is, so already we have done this for y, we got 3y square minus 3. So this can be done again for y. So we will get dou square f by dou y square, so which is 6y minus 0, so it is 6y, right? So next we are going to find the points of stationary, that is so how do we get the stationary points? So we already discussed that at stationary point the differentiations become 0, right? So we take this dou f by dou x, right, that is p, that is equal to 0, and the same way I am going to replace this dou f by dou y, that is equal to 0. So we are going to replace the differentiations are 0. So by solving them we will get the points of stationary. So what is dou f by dou x here? So we get 3x square minus 12. So 3x square minus 12 equal to 0. So by solving them we will get equal to 12, and we can cancel, becomes 4. So x value will become plus or minus 2. So by solving the q equal to dou f by dou y equal to 0, the value of dou f by dou y is 3y squared minus 3, so which is 0. So we can write it as 3y squared equal to 3. By solving them I will get y equal to this plus or minus 1. Okay. So now we have got the values of x and y. So the stationary points are the xy coordinates. So we have to go for the all the possible combinations of this plus or minus 2 and plus or minus 1. So that will complete the stationary points. So I am writing the stationary points here. So they are 2 comma 1, and then 2 comma minus 1, minus 2 comma 1, and minus 2 comma minus 1. Okay. So these are the stationary points we have, and we are going to calculate what is r value for this. So r is already 6x, and we are going to find out what is rt minus s square also. Then we find the maximum or minimum. Yes. So this 2 comma 1 has to be replaced for this r value and rt minus s square value. So if you replace, so r is 6x and t is 6y and s is 0. So this is what we already found out. So if you replace this 2 comma 1 in the place of r, it becomes 12, and this rt minus s square is nothing but here so this becomes, so multiplication of these two, that is 36xy and minus 0. So this is 36xy. So if you put this 2 comma 1 in the place of that rt minus s square, 36 minus xy, it becomes 72. And this 2 comma minus 1, if you replace it here, it becomes 12, and that rt minus s square will become 36 times 2 into minus 1 will become minus 72. So this minus 2 comma 1 can be replaced here. So it becomes minus 12 and minus 72. So minus 2 comma minus 1, if you replace it here, it becomes minus 12 and plus 72. So, this RT minus S square value must be greater than 0. So, whenever it is positive, we can make a we can have a maximum or minimum. So, if it is negative, so these points are called as saddle points. So, it is neither a minimum or a maximum. So, whenever it is positive, it is greater than 0, we can take a decision of whether it is minimum or maximum, depends on R value. So, if it is greater than 0 and if this is also greater than 0, then this is called as minimum. And whenever this is positive and this is negative, it is called as maximum. So, now we got the point in which we will get a minimum or a maximum, right. So, here this 2 comma 1 will give you a minimum value and this minus 2 comma minus 1 will give you a maximum value. If you want to find the values of this minimum value and maximum value, we have to replace in the given function f of x comma y. So, we are going to find the maximum value. So, I take this respective point, that is minus 2 comma minus 1. So, if I replace this f of minus 2 comma minus 1, it will become minus 8 minus 1 plus 24 plus 3 and then plus 20. So, it becomes, yeah, if you add them, it becomes minus 9. So, on the other side it is 47. So, this is 38 and this is the maximum value, and the minimum value this f of the point is 2 comma 1, and if you take this, it is 8 plus 1 minus 12, yeah, minus 24 minus 3 plus 20. So, it becomes, so 29 minus 27, which is 2. So, this is my maximum value and this is the minimum value of the given function, right. So, we will go for the one more example. So, find the extremum values of f of x comma y equal to x power 3 plus y power 3 minus 3a x y, right. Yes. So, the same working procedure we are going to follow here. We are going to find out the first derivative with respect to x and y and the second derivative with respect to x and y again, right. So, we will write the function first, f of x comma y is equal to x power 3 plus y power 3 minus 3a x y. So, already we know that p that refers to dou f by dou x and q value refers to dou f by dou y, and r, s and then t values. So, this r means dou square f by dou x square, and this is dou square f by dou x dou y, and here it is dou square f by dou y square. So, if you differentiate this partially with respect to x first, it becomes 3x square plus 0 minus 3 ay. So, it is, yes, so we can write it as 3 ay. So, if you go for the skew value, if you differentiate this with respect to y partially, it becomes 3y square minus 3ax. So, on the other side we have r, that is dou square f by dou x square. We have to differentiate this once again with respect to x. So, take this value 3x square minus 3ay. So, differentiate that again, that is 6x minus, yeah. So, here we do not find any x value, that becomes 0. So, the 6x will become the value of r. So, yes means either you can differentiate this with respect to y or this with respect to x. So, if you differentiate this with respect to y, it becomes 0 minus 3a, that is we can put minus 3a, and the last value, that is dou square f by dou y square. So, this y differentiation, one more time we have to differentiate that with respect to y partially. So, that becomes 6y, right. So, these are the values of p, q, r, s, t. So, after finding this, we have to go for the stationary values. So, the stationary values are, yes, so the stationary points in which the differentiation gets 0. So, we make this p equal to dou f by dou x, that is equal to 0. So, dou f by dou y value is this one, that is 3x square minus 3ay, that is equal to 0. So, by simplifying them, I can write x squared is equal to ay. On the other side, we have this q equal to dou f by dou y, that also must be 0. So, this dou f by dou y value is 3y square minus 3ax, that is equal to 0. By simplifying them, I can write y square equal to ax, right. So, now we have two equations, x square equal to ay and y square equal to ax. So, by solving them, we should find the values of stationary points. Okay. So, I will take this x squared equal to ay. So, in one way we have to replace in the other equation. So, I will square this. So, if I square the equation of this, it will become x power 4 equal to a square y square, right. So, now this x power 4 can be written as, this is equal to, so here we have a square into y square. So, instead of this y square, I will replace this ax value here. So, it becomes, already a square is there. So, I will write a power 3 into x, right. So, this is the simplification we have, and this can be further solved, right. So, I can write it as x power 4 minus a power 3 x is equal to 0. So, if you take x out of this, it will become x power 3 minus a power 3 is equal to 0. So, either we will get x equal to 0 or x equal to a. So, these are the 2 points we get, right. So, we get x equal to 0 or x equal to a. So, you replace this equation value in any of the equations. So, if you replace it here, it becomes so x equal to 0 means this y also will become 0, and here I replace. So, if I replace this a square, again y will become a. So, the points are 0 comma 0, and here we get a comma a. Okay. So, these are the stationary points we get. So, we write the stationary points, that is 0 comma 0 and then a comma a and this r value, okay, which is 6x, and we write RT minus S square, then whether it is maximum or minimum. Yes. So, already we know that R value is 6x and S is, yeah, and T value is 6y. So, this S value is equal to, yeah, minus 3a. Yes. So, if you find out this RT minus S square, it will become 36xy minus the square of this is 9a square, right. So, if you replace 0 comma 0 here, that is 6 times 0, so it is equal to 0, and here if you replace 0 in the places of x and y, we will get first term will become 0, then the next term is minus 9a square, right. And the second term a comma a, second point, if you replace it in the place of x, it becomes 6a, and this RT minus S square will become 36a square minus 9a square, that is 27a square. Okay. Yes. So, now the concept of maxima minima is we look at the positive value of the RT minus S square. So, if it is negative, so the if you take any value of a, it is going to be negative. Okay. So, we say this is negative, and we cannot obtain any maximum or minimum value from this. So, this is called as saddle point, and this is always positive. So, irrespective of a value, when we are squaring, it becomes positive, and 27a square is always positive. So, if it is positive, then we have two cases here, right. If a is negative, right, this 6a will be negative, and if the a value is positive, then the 6a will become a positive 1, right. So, we divide this here. So, if a is positive, so if a is positive, then this will become positive. So, that is called as minimum point. That is and the next one is, if you take this a as negative value, right. So, this 6a also will become negative. So, we get the maximum value from this, right. Yes. So, we will replace the values of this. So, if we replace this a comma a here, it becomes Thank you, Sulira.